What's up, fellow gamers? In today's video, we're going to show you how to code in a cool looking muzzle flash by utilizing the spriteNearby command using the HD pack functionality of the Mesen 2 NES emulator. Keep in mind, this is an advanced video of Enhancement pack functionality. If you're just getting started, you may want to check out some prior videos I've done on this topic that are included in the video description below. Okay, so assuming you've already watched some of those basic videos and know how to have a highres.txt file created, go into that highres.txt file and find a spot near the top of your coding. Each game will be a bit different, but the same general principles shown here should carry over. In the case of Metroid, we're going to add this coding here, and I'll explain how each of the lines work. This first grouping of coding involves adding an 8x8 area where the muzzle flash can appear in front of the arm cannon. It uses an addition function. For more details on using addition functions, check out a previous video on the subject that's included in the link below. These next three lines are the actual spriteNearby conditions that tell Mesen to look for certain scenarios. This first section tells Mesen that what follows is a condition. The next section indicates the unique name of your condition. You can call it whatever you'd like, as long as it's unique. The next section tells Mesen to look for certain sprites that are nearby. Keep in mind there's a separate tile nearby command. If you want Mesen to look for tiles instead, use that command. The next two numbers tell Mesen to look for scenarios where the sprite address is 2 pixels away in the x-axis and 0 pixels away in the y-axis. After that is the address of the sprite Mesen should seek. You can obtain this value by navigating to Debug, Sprite Viewer, right-clicking on the sprite, selecting Copy Tile, then pasting in a text file. After that, the Y tells Mesen to look for all color palettes of the coding included on this line. The next line is the same as above, but asks Mesen to look 10 pixels away in the x-axis. The next one after that is the same, but asks Mesen to look 18 pixels away in the x-axis. Due to graphic mirroring that can sometimes take place, the negative sign here can sometimes be confusing with respect to which direction Mesen should look. Should it look right, or should it look left? It can be a bit complicated to explain. I forget myself on occasion, but to try and make a long story short, if your graphic coding is not working as intended, just try taking out the negative sign or adding it back in to troubleshoot. The next three lines represent the actual graphic replacement information. The bracket here indicates which condition above needs to be true for the coding on the right to take place. The first line of the three tells Mesen to look for the condition using the Power Muzzle Flash 1 designation. The title 40 coding tells Mesen how many PNG files down, and the total PNG file list should be referenced for this rule. In this case, the 40th file down in the PNG file list contains my custom muzzle graphics. This next line is the coding that it's being replaced. In my case, it's a custom created tile using the addition function. But it doesn't need to be a custom created tile. This also works for existing tiles as well. The 16,16 indicates the X and Y coordinates of the custom art that Mesen should reference for graphic replacement. In Photoshop, you can left-click with the rectangular marquee tool for it to tell you what X and Y coordinates you should use. When creating your box, start with the upper left-hand corner, click, and hold until you reach the upper left-hand corner of the graphic you'd like to use. The W and H values represent the X and Y coordinates you can use in your highres.txt file. The 1 indicates the brightness, and the N indicates this should not apply to all color palettes. You can see there's a separate line for each of the conditions where the power beam is 2 pixels away, 10 pixels away, and 18 pixels away. Those all correspond to the 3 different frames of the custom artwork at Y location 16 and X locations 16, 32, and 48. When you put all of this together, as the power beam moves away from the muzzle, it will reference the 3 different frames here in the custom artwork file. Now that we have all the coding in the file, let's save it and see how it looks in the game. Alright, looks like it's all working as intended. Now, this whole process may need to be duplicated a few times depending on what's going on in the game unique to your project. For example, with Metroid, the sprite addresses change depending on which location the player is located in the game. As a result, this coding would need to be written for each new area. The same is true for different palettes. In addition, there are other things that can be added, like making a muzzle flash a bit random, but coding for that is a bit complex and beyond the scope of this video. In any case, this should cover the basics of what you should need to know to use the spriteNearby condition. There are many possibilities and uses for this command, and a muzzle flash is just one of many. I hope you found this video useful, and as always, happy gaming.
Why are we still here? Just to suffer? Every night, I can feel my leg